There are always a lot of questions about the problems like number 1 and 2 in the 6.2 homework problems. They use the invNorm function, and so I put this video together to just illustrate examples of each of them. The A part in number 1 is pretty much a bullshit question, so you shouldn't worry about it very much. It's trying to tell you to outline a solution method that uses the tables in the book, which is not how we're going to do it anyway. So I believe that that A, the longest of all the answers, is the right one. And just check that and go on, and we'll get to the ones that actually matter. Here we see that we would like to find a z-score with a two-tailed probability of 0.49, and this is a good problem. So let me grab a copy of this question. Okay, so the two questions are to find a two-tailed probability with 49% of the area and 80% of the area. As we discussed in class, these problems all have the same basic form. In each case, you're either being told, well, actually in each case, we have a standard normal distribution. Since they're asking us about z-scores here, then we know that they're really talking about the standard normal distribution that has mu equals 0 and sigma equals 1. This is standard normal distribution. It's the one where we can think of the values along the bottom as being z-scores. And this is just their way of not having to make up a setting about children's indexes or heights or SAT scores or whatever. So this is a generic question about a distribution. The two-tail part means that we expect that we need to draw, that we have lines, vertical lines that are symmetric, and we're shading away from the center. So this is when they say two-tailed, they mean that they think of these little things going out the side as the tail. So you're shading on both sides, and it should be symmetric. So whatever this mystery number is and this mystery number, they'll be on the same distance from the middle. So that's the setup for both of these problems. The only issue is how am I going to be able to use invNorm to do that? And the answer is, remember that invNorm always wants to do a problem like this, where you tell it an amount of shading, and then it tells you where the answer is, where the line goes. So if you say invNorm of how much is shaded, and then 0, 1, because that's the mean and standard deviation, then the answer to that is going to be where to draw that line. But the trick is it only answers the question when you're asking for the shaded region to be shaded to the left of the line. And that's exactly what we have going on over here. So now I have to think a little bit and say, well, if the total amount of shading in this picture is supposed to be 49%, then the amount that's shaded on the left side there is just 49 divided by 2. So that's 0.245 is the proportion of shading that's over there. Of course, the same amount's over here. This is also 0.245. But we don't need to know that. We're just going to use this side because this is the side that matches up with what invNorm does for us. So if I type invNorm 0.245 501 in my calculator, oops. Wow, that is not what I meant to do. I get negative 0.6903. So that's the value right here, negative 0.6903. So that means that this answer is positive 0.6903. They're the same distance from the middle. So, oh, I only need 2 decimal places. Well, that's good. So in my box, I'll put 0.69. And then the second, for number 2, we see I already did one of these, so we'll do the other one. We have the problem that says let's find the z-score, so the interval within z standard deviations, the mean, contain 56% of the probability. So this is a shading problem where, where they're giving us, let me make this a little bigger, where they're describing a different picture, but we still are being given a probability, a proportion. So that means we're being given an amount to shade, and we're being asked for the z-score, which tells us that again we're using the standard normal distribution or the z-score distribution. So that would be sigma equals 1 and mu equals 0. So this is our z-score distribution. We want to know how to get 56% of the probability to be within a certain distance of the mean. So that means we want to come out symmetrically on either side of the mean, and we want the shaded amount to be 56%. So this is just like the empirical rule. If the, oops, that's not 56, 56%. If we had been asked how far out do I need to go to capture 68% of the data, we know that the answer would be that we need to go between -1 and 1. A z-score of -1 to a z-score of 1 would capture 68% of the data by the empirical rule. Once again, we have to try to get this to match up with what the invNorm function will even do for us. The invNorm function is waiting for us to give it a percentage, and then it's going to give us where to draw the line to get that percentage to the left of my line. So it's always going to tell me where to draw the line so that the shaded part is the shaded part to the left is the number I put in. So in this case, I'm not given that much shading at all, but because there's 56% in the middle, I can figure out how much is over here and how much is over here because the picture's symmetric. So the amount of unshaded stuff comes from 1 minus 0.56, which is 0.44, which means that half of that is over here and half of that's over here. So if I can answer the question about how to make 0.22 shaded, then that will actually tell me where to draw this line. And I can do that by asking invNorm. So invNorm 0.2201 is going to tell me where to draw a line so that 22% of the graph to the left of that line is shaded. Oops. So the calculator tells me that negative 0.77 is the, I think that's what it said, yeah, is the z-score of the line right here. So that's negative 0.77, which means this must be positive 0.77. And so my answer is going to be 0.77.